So in the previous video, we introduced the LU factorization, the basic idea. And before we doing a formal LU factorization, I think it's important to introduce the echelon matrix.
So consider this system. We have -1, 2, and 0. 0, -1, 2. 0, 2, and -1. Apply some Gaussian elimination. So to make this a upper triangular matrix, which is the forward step of the Gaussian elimination. So we do this. The rows, first row unchanged. The second row is unchanged. For the third row, we want to multiply 2 and then add that to the last row. So this will become 0 and 0. This multiplied 2 will become 3. So this becomes a upper triangular matrix, and we call that U. As you can see, this Gaussian elimination forward step is basically take a matrix and then reduce that to an upper triangular matrix. Now we want to encode from this step to this step by some operators. So that's how the echelon matrix comes in. So we want to represent A being multiplied by some echelon matrix E1. So I will explain what an echelon matrix is. But right now, just consider it as a kind of matrix. So I have an A, and then multiply E1, E2, and 2, some order of echelon matrix, and I want it to get me U. So what I'm doing actually right now is to encode this Gaussian forward elimination step by a few matrices multiplication. To define an echelon matrix, it's basically a matrix, and we want to match because A is m by n, and we want to get back the results, so it should be the same dimension as the A. So this should be m by m. So that's the dimension of one echelon matrix. So this is m by m. An echelon matrix has 1 on the diagonal, zeros in the rest columns, and here are some terms that we need to define. So just the cross, it can be either 0 or other numbers. So that's how we define it so far.